I think Terence asked for that.
Okay.
Excellent. Sorry, Hilton, can you just start again?
Yes, so my name is Hilton. I'm a master's student in electrical engineering, and I work with electro-optical modulator based in graphene.
Good. Érico.
Hi, everyone. I'm Érico. I'm the president of Universidade Federal do Rio Grande do Sul chapter. I'm a master's student in physics, and I study about weak measurements in optics.
Okay, UF ABC.
Hi, everybody. My name is Daniel. I am the president of Universidade Federal do ABC, Santo André.
Okay, Manuel. Manuel.
I think he froze.
Manuel's frozen. Okay, Jefferson.
Well, hey everyone, this is Jefferson. I'm currently president of all the association students here at UNLAB in the Ceará. And we are, I think, the most youngest chapter of Brazil. We have just 3 months. So we are starting our chapter. We have a few members. And that's it. Well, I'm a student of engineer of energy.
Okay, very good, Jefferson. Welcome. So
you,
Professor Lucia Saito, she's from Mackenzie. Lucia, please.
You're muted, Professor.
Hi, nice to meet you. My name is Lucia Saito. I'm from Mackenzie University. I started this OSA chapter in 2008. And nowadays I am the advisor of the Mackenzie OSA student chapter.
Okay, I contacted Manuel here. His internet connection just fell. He's coming back, but Manuel has been, before he's the chapter president of UFP, was a chapter student UFP, so he'll be back. So Tom, can you just say a few words and then we can start again with a round of presentation.
Most of you were on the last Zoom meeting that we had on this topic, but I'm Tom Baer, former president of the Optical Society. I've been working with Anderson and several people at OSA, mainly Chad Stark and the OSA Foundation, to help groups who are interested in building instruments to support the COVID-19 efforts within their countries. Brazil is really taking a very strong leadership position in this, which we're very pleased to see. We're also working with a number of groups in Africa, in Ghana, Ethiopia, and Kenya, and also in India and Bangladesh and Mexico. We're very interested in the progress that you are making in Brazil because you were the first to really begin to organize. And I think working together like you are doing here and sharing the input you're getting from your hospitals and sharing that not only with each other in Brazil, but with the rest of the world will be very, very helpful as people go about trying to assist the hospitals in their areas around the world. So I'll turn it back to you, Anderson.
Okay, so maybe now we can start the report. So let's start again with Hilton. You can, I don't know if you have a presentation. I asked when we talk if you have, you have. So whoever has a presentation can present or just explain what's going on. So Hilton, go ahead.
Okay, it's really simple actually. Can you guys see my?
Yes.
Yes.
Okay. So I'm going to talk about this current status of our chamber. About the hospital letter, we still don't have it, but we are in contact with the hospital and they showed a lot of interest on receiving it. Along with the Santa Casa Hospital that we're going to donate, there's the Institute of Medicine of Santa Casa. The physical space is almost the same. They're really close to each other. And we talked with both of them. And the Institute, they're really interested in helping us on the part of the biological tests. They actually have a partnership with another institute that is currently working with the COVID-19. There, they don't have the structure for it, but they are going to help us with microbiological tests and with this partnership test with the COVID-19. One thing that it's kind of taking long for this letter to arrive. They're organizing themselves on how they're going to share the costs. They're trying to see internally how they're going to pay for this. And at first, they asked us if we could help them in this part with the money, but they are organizing themselves to see how they're going to pay for it. On our university and at Mackenzie University, we have talked with the pharmacy sector. We also don't have the structure to work with the COVID-19, but since we're planning to start building chamber inside the university, we could have some first tasks there with the pharmacy sector. Talking about the chamber and the improvements, we were really planning on it. So at first we're going to have the interlocks and the lamps to inform that the chamber is working. And our electronic part, it's probably going to be based in programming Arduino. And I'm going to talk about this a little bit. And as for the inner part of the chamber, we're planning on using aluminum tape instead of paper. I heard that a lot of chambers are having kind of some problems with aluminum paper because it's really sensitive and it's really easy to make holes on it and or torn it. So we are really considering using aluminum tape for it. As for the when the chamber is it's on, we are kind of worried about how can we be sure that the lamps are working, right? And of course, since the lamps are new, we expect them to work properly, but I think we need to have something that we can be monitoring these lamps and not only tell that there's a problem, but tell which lamp is like the defect one. So we talked about some options that we had. We thought about current sensors, but at first it would be good, but since the sensor can be showing that the current is passing through the lamp, maybe it's not enough to turn it on. So it might have problems with it. We thought about putting cameras inside the chamber, but also we don't know the problems that it can cause, like shadow areas or what is the angle that we're going to see, where we're going to project the image. So maybe there's some problem with it. I think ideally we should have an UVC sensor for each lamp, but since one lamp can be defective, how can we know that it's not another lamp that has influence on the sensor, right? So one of the things we are really excited about, it's the idea of putting glass windows on the sides of the chamber. This is like a model that we have. We can see in this left side that we have a window here made of glass. Since the UVC can pass through glass, it would be like safer for the user to verify that the chamber is on. And if there's a problem with some lamps, they can see directly which one is that one. Of course, it's not, we're not going to leave it open. Probably it's going to be like really a window that we can open and close. And when it's closed, we're probably going to have also the aluminum tape inside of it. And here in this front part, it's not in this presentation, but probably the part of electronics and sensor and lamps is going to be here in the door. So we don't have still the ladder, and we are working on what improvements we have to do. This is some things that we thought about, and I would like to know the opinions about it. And as for the ladder, we're really hoping that we're going to have it in the next week. Okay, so that's it.
Great, thanks. That's fantastic. Very, very nice.
Very good.
Tom, do you want to make some comments before we move to the next one?
I think the window idea is excellent. I think it may be more difficult to make a large window like you're describing. You might consider a series of small holes and just put microscope slides. They are they absorb the UVC very effectively. They're like 4OD. So a series of holes that are positioned so that you can monitor each lamp just by looking at the transmission through the holes or by looking through the holes. Might be easier to drill those holes than it would be with a hole cutting saw than it would be to put in a big window. Either way, I think it's an excellent idea to put in a window of that sort. I have been looking at a single UVC detector, and I have purchased a number of these, and I can send them to Anderson. These are solar blind, so they don't see the visible light, they just detect the UVC. And what I find is that if you put them so they're not looking at any one particular lamp, if I mount them on the side of the chamber, they monitor the average power in the chamber pretty effectively. And since each lamp contributes about 6 to 10% of the light in the chamber, if one of the lamps goes out, you can kind of see that by just looking at one single point detector. So I think that the combination of that plus the windows would be an excellent way to improve the design and provide you with a way to monitor the lamps. I do find that the lamps, particularly those mounted on the doors, can slip out of their electrode fixtures and not turn on. And so it is a good idea to have some way to monitor whether the lamps are on or not. The ones that aren't on the doors seem to be pretty reliable. The ones on the doors, that is a weak point in the design. And having a way to monitor that would be very effective. I have also incorporated an Arduino, just for your information, and I have identified some power relays that work very well to turn the lamps on and off and to control things. I can send you those designs. It's fairly simple, so if you've done any work with Arduinos, it's not a problem to design these things. But my Arduino measures the temperature and the humidity in the chamber, as well as monitors the power, and then I've got an ozone meter that I can put in there if I need to. And it just takes those readings and stores that on a secure digital disk and allows you to transfer them to the computer if you want to. So I have those, the code for that and the design for it if it's of interest, but I think it's an excellent way to go. I will warn you that with all of these ballasts, the surge current that when the lamps turn on is quite high. So the average power is about a ½ kilowatt going to the lamps. And so that's several amps that are going through whatever power circuit you have. But when the filaments first turn on, there is a surge that goes through. So the first relays that I used to turn the lamps on and off actually failed. And that's because the contacts fused, because that instantaneous current was so large that even though these relays were designed to handle the average current, they couldn't handle the peak current. So you need to be a little careful about what relays you choose to be powered off the Arduino. And I ended up with relays that were spec'd at about 30 amps, and that was sufficient to provide the types of current loads that occur when the lamps go on. The initial relays I used were spec'd at 10 amps, and you would think that would be enough, but it wasn't. And so you need to be careful if you're going to use relays to turn the lamps on and off via the Arduinos, that they have the appropriate amount of surge current capabilities. But other than that, I think what you're doing, Hilton, is very, very good, and the design looks solid. And I think the aluminum tape should work fine as a replacement. And I agree, the aluminum foil is very easy to repair, but it does have an issue that it is fragile, and you do need to sort of recover the interior of the chamber. I don't think it's necessary that it be perfectly flat, and if it has some texture to it or it's wrinkled a little bit, that is fine, because that basically makes the light more homogeneous within the system. But I think the aluminum tape is an excellent idea.
Okay, thank you. If you can send us the codes and stuff, because we're going to work with Arduino, but if we can have a base of it, it would be great.
I'd be glad to do that. Yeah, the code is very simple and straightforward for anyone who's done Arduino programming. There's really, again, I have a very inexpensive temperature and humidity monitor, which is not a bad in the chamber. And then it can read the voltage off this UVC photodiode assembly and store that on a secure, either dump it through the serial monitor on the Arduino or put it directly on a secure digital card. I will send you that and send you the Arduino components that I used. Yes.
Okay, thank you.
I can either send it to you or I can send it to Anderson. So if I don't, either way is fine. Probably
Okay.
best if I send it to you, Anderson, and then you can distribute
Yeah,
it to.
okay, sure.
Yes, yes.
Okay.
And the idea of the holes was really interesting instead of a whole window. I think we're going to use that instead. It was really great.
I would recommend it. I find is drilling through or machining these metal cabinets that are hardened steel, and it's very difficult to do. I would recommend, if you're going to do it, use what's called a stepped hole cutting saw. So it's a drill that has a series of different size drills, essentially in a cone-like shape. I'll send information on that to Anderson as well. And that you can very easily with a hand drill. You drill a starter hole, and then it gradually makes the hole bigger and bigger and bigger up to the point where you want it to stop. Those are fairly standard components, and you can do that with a hand drill very easily on these hardened steel metal cabinets. Actually, machining out a large square like that will be much more challenging. I wouldn't know how to do that. Yeah.
Okay, thank you.
Lucia, just to make some comment, Lucia.
No, it's great. About the hospital, I think they ask for us about the tests, if it's possible to include the costs, but I said that I need to check because
Can you repeat it? It cut for me. I don't know if it cut for the others. Can you repeat?
Okay. The hospital are very interested in the tests, the biological tests, and they are trying to provide the resources. But the challenge inside the hospital to approve the letter to send for us is that they don't have the financial support to beginning the project inside the hospital. So they asked us if it's possible to include the costs about the biological tests, but I don't know if it's possible or not. The problem is that they told me they are going to send me the costs, but I don't know really what I don't know. I would like to know about the tests, if you have any recommendation about this.
Yes, Lucia, you'll need to talk to the hospital to find out exactly what tests they feel is necessary. We have done testing, and Anderson, I think I sent you the latest preprint.
Yes.
And if you could pass that around,
yes,
and you could show that to the hospital and talk over with them. What we use are what are called bacterial spore strips, and these are about 1 centimeter by 2 centimeter strips that are embedded with about 1 million known bacteria. And then we demonstrate that when you expose them to 5 minutes within this chamber, that all the bacteria is killed. And the way you do that then is you take the exposed strip and you put it into growth media, and you wait 2 days and see if there's any evidence that the bacteria has grown. If there's any bacteria, even just one single bacteria in there, after about 2 days, it will change the color, the pH of the media. If that is enough, we can supply that. I can send that to Anderson or directly to you. I have here a surplus testament, which I'd be glad to, if we can get things sent to Brazil, I'll be glad to send them to Anderson, and you can use those. What we have done is do about 20 strips, about 4 or 5 different tests. In the paper that we sent to Anderson, we actually took the strips and put them inside the type of masks that we are going to be decontaminating, to show that even when they're inside the masks in the filter layers, that you still get enough UVC light penetration to do the decontamination. So if that's enough tests for the hospital, then I think we can supply the materials to do that if we can ship them to Brazil. But if they need more testing than that, And I know Anderson has done some very nice tests as well with CPEC. So, and those look like very inexpensive tests to do as well. And that might satisfy. So what's important to find out is, what does the hospital need to see in terms of tests, or what is your regulatory? So Anderson, I don't know if you want to talk about what you've done.
Yeah. If they are trying to do the you know, the virus test directly, then that's expensive, and that's going to be for the microbiological test. It's not expensive. I mean, we can have the material from Tom, but here my colleague at the university, she did it using her own material, and she said that's I'm going to replace for her, but it's not very expensive. So I think probably the hospital is trying to do the virus test. Then that's expensive.
That's the point.
Yeah. So if it is that one, so maybe my test is still waiting for approval from the ethical committee. So the lady, I talked to the lady yesterday, the researcher there. It's because it's done at Fiocruz. They have to, because it's the SARS-CoV, they have to approve in Rio. But should be done this next week, and then we should have the data. This data is enough for everybody because it's the same chamber, all the same characteristics. So there's, if you can repeat that, that would be great. But this test is really, one is enough. But the microbiological, just to have your own, that's cheaper. So if they can do the I'll send you the material. If they can do that without, I mean, you know, anything, then okay. If not, maybe Tom can send the strips, and then I'm sure they can do the rest. But talk to them about, ask them exactly what they need and what kind of test, and then we can decide. But I'll send you the material.
Okay.
Good. Let's move on to Daniel. Can you talk a little bit?
Yeah. I'm sorry I don't have presentation, but I talk about the status of the chamber. I sent to the letter for the OSA. I get the letter of the hospital. The OSA Foundation sent me the money 1 week ago. And buy the component, the part online. This week arrived some part. I hope the next week, the other part. The start of the construction of the chamber. Now I looking for information about the biological test. Not this clear for me, but I look in information for the microbiological test and viruses text. I think in 3 weeks, I put the chamber in the hospital. Okay. This is my status. I don't have question.
Okay, that's fine. Manuel, can you make some comment? I see you are back.
Hello, everyone. Sorry about the problems in the internet. My name is Manuel. I'm president of student chapter of the Optical Society in Recife. I'm also student of the doctorate in material science by the UFPE, and work with the non-linear optics in 2D materials, nanostructures, and materials, photonic materials in general. I have a little presentation about this. I need to share my screen. It's okay? It's sharing?
Yeah.
Yes.
Yeah. Put in presentation mode, it's better.
Yeah.
Okay.
Sorry.
Yep.
some problem here. So it's open again, the PowerPoint, but also chapter in Recife, yeah, we wait for the resource for buy the components, but some things we just buy. So it's shared now.
Yes.
Okay. So this is the member with work with the UVC chamber. All chapter have more of 20 members, but how he's living far of the university and the need of the public transportation. So only the members if live near to university, it's work in this project. Okay. So we wait for resource for buy the components, and we have the letter of the hospital, and he the hospital are interested in implement this device, and he's talk about the who would this need of the implementation. So his on topic is the approbation in the regulatory process. So this later uh, it's here. I sent for the optical society and to wait for the response. And we have a contact in the Center for Biological Science for the tests of the microbiological tests. So this is the chamber which we buy the a chamber with 2 meters of the height, but 0.3 meters we use for the electro components. So the electro components is here, and the rest of the chamber we use for the disinfection. We will buy interlocks for time monitoring of the disinfection, and for monitoring the lamps power, we think use the photodiode or photodetector, for example, Arduino, and a code in Python, and construct the circuit for monitor the power of the lamps. Here we have the display which show the power. This is developed by a member of chapter. It's very good in Python and Arduino. And some material was purchased, how aluminum wires, support for masks in construction, and the double-sided tapes for aluminum. This type 3M type. So this is the progress. We wait for the results for by the lamps and the another things. Okay.
Anderson, you're muted, I think.
Yes, I was good. Great, thanks, Hilton. Manuel, take your presentation off so we can see everybody else. And any comments, Tom or Lucia? Or,
No,
I have.
Go ahead.
Yeah.
You
Okay.
told that probably the electrical part is going to be inside the chamber, right? I think you have to be a little bit careful how you're going to glue the paper inside the chamber, because if the electrical part is inside the chamber, they're going to generate heat, and I don't know if it's going to affect the glue, or I don't know how you're going to take the paper on it. So possibly, I don't know if it's better if the electrical part is outside the chamber, because then this way you won't generate heat inside of it.
Yeah.
Right. I don't know if that's going to be a problem.
About this, and we think how solve this problem.
But just to comment on that, it's a good point. But the ballast power supplies typically are switcher power supplies, so they are roughly 90% efficient. So most of the power and heat is in the lamps themselves. About 75 to 80% is in the lamps. That's what causes the heating. So I think it is good to be concerned about the additional 10%, but it should be a minor amount of additional heat. And the cylindrical design that I built up has, well, in fact, all of the designs I have the ballast supplies inside the chamber because mine are in fixtures that I've used that have the ballast inside, not outside the chambers. From what I can tell from the heating, most of the heat comes directly from the lamps themselves and not from the power supplies. So I think being aware that the lamps have a temperature coefficient, their power goes up until about 40 to 45 degrees centigrade, and then starts to degrade fairly rapidly above that because the mercury pressure gets too high. And so in the lamps, so you do want to keep the temperature within the cabinet down below 50 degrees C if you can. And so it is good to be aware of it. I think putting the ballast inside will be okay.
Okay, that's a good point, Tom, about the typical temperature, because then that's why it's worth to have a temperature meter inside somehow.
Right.
At least that's great. Okay, Jefferson, do you want to go before Erico? I know you are new. Do you have anything to say, or do you want to any comment?
Well, as you know, I'm new here. It has been my first meeting here. It has been the first time that I'm talking with you. And I'd like to make some update about our project. We are still in contact with a few professors of our institute. As I said, we are new, and we are a new chapter. So we have a few numbers of members. And specifically at the moment that we are in the countryside, the UNILAB in the Ceará, it has 10 years. So it's a new university of our state. And most of our members, we are living in the countryside. And our advisors, they live in the capital, in Fortaleza. So we are.
Who is your advisor?
Sabi Mois.
He's from physics?
No, he's from engineering.
Engineering.
Yeah.
Okay.
So at the moment, I don't have any presentation, but I took some notes here of everything that you said, everything of the presentation. I took some notes, and I'm still in contact with the Anderson, and with the also UVC. Daniel has been taking me some questions that I talked for him, and it's been amazing. I'm still in contact with our group too, on the WhatsApp. So that's it. I've been taking some notes, and probably in our next meeting, I'm gonna have something to present for you. So
okay, very good. So we will talk more to speed up and see if there are other people in the capital that can help you.
Okay.
particularly with the hospital and everything. I know more people from physics, but sure they'll help you. We'll talk
Good,
more
amazing.
later on the WhatsApp.
Okay.
So, okay, Erico.
All right, let me start here. Let's see. Share. Okay, I think you guys are seeing everything. Let's
Yes.
start the presentation. Okay, can you guys see the mouse too?
Yes.
Yes.
Okay,
Yeah.
so I'm going to start our report. The chamber, me, Amanda, and Vinicius worked on it. So I'm going to show you how it is right now. So we took like 3 to 4 days to assemble everything. This is just to build it, and including the cabinet. We did a different design. We didn't use a metal cabinet. We used a wooden one because it was easier to drill holes in it and open anything else. And so we changed a little bit the design too. We still had the original proportion of 90 centimeters by 60, but we took half the height because we thought it would be easier to move it around. Instead of doing like 2 meters tall, we did half. So that's it. That's how it looks like from the outside. As you guys can see, it opens here, and we also changed it a little bit because now the longest dimension, the 90 centimeters, is on this side, and this one is 60. So the lamps are now are fixed on this side and not on the door. So we thought that would be safer to use. So, and now that Tom said that the lamps can disconnect in the door, I think this is a good solution to that. It's a little bit longer, but well, it's not that much longer than the original 60 centimeters. And about the ballast power supply, we put it up here. This is another compartment that we closed off. You can see it's we have the aluminum foil here, but on top of it, the ballast supplies are there, so it's all closed in. And we think it's also a little bit easier if we need to make any other alterations on that. So this is how it's turned on. This was taken behind a glass window, as you can see.
Good.
Everything looks working. We also have a red light to indicate it's working. The safety interlock is also working. So we only had 4 lamps on the opposite side, 8 total from the original 16. So we also changed a little bit the design for the mask support. We did this this aluminum track here. We think we can build a frame, and then you can just slide it in, slide it off. We are still working on this frame, thinking about how to use one light enough to be able to take this easily in and out. We are still thinking about how to do it. So we measured a bit the spectrum. It was roughly on where we expected to be. We didn't put the digital timer because it will take too long to arrive, and we just wanted to see if everything was working. But it's somewhat easy to implement that since everything is working right now. We also didn't do a power measurement because we had a thermal detector, and until now I didn't know how to use it correctly. Professor Anderson gave a very good solution to that. So next week I hopefully will see if I can do a measurement of the power inside, but it looks like it's working as intended. And we are also planning exposure tests with biological samples from another professor in our university that has those samples to be able to use it. And we are still unfortunately waiting for the letter from the hospital. We had all the money in our bank account, so that's why we bought it beforehand. But they're very eager to receive this. They just didn't sign the letter yet. But I'm pressing them to do it so OSA knows we had made some progress. And I think that's it. This is us building the chamber, having some fun.
Okay, very nice. Very, very good. Just don't turn the light on when someone is inside.
Yeah.
That's great. Okay, so send those pictures to the hospital and tell them you are almost ready media letter, otherwise they don't get it. I
Yes.
think they'll be very excited seeing
Yeah,
that.
they were asking for some biological tests too. So I think next week, if not next, the other one. With that done, I think they'll be way more eager to sign that. But they will receive
Yes,
this. They were very
yes, but
excited to work with us.
yeah. In any way, when I send the material that Tom sent me, you can tell them, look, this is similar test that what we are going to do because we have similar equipment. Everything is very similar power. So we know the test is going to work. But anyway, you're going to do your own. Tom, some more comments?
No, I think the design looks very sound. The power levels may be a little bit less because you're only using 8 lamps, not 16. But I think it will be very comparable. You might want to expose the mass for 10 minutes rather than 5. But I think the design looks very, very, very good. No problems at all with that. Good job.
Yeah.
With those tests, hopefully
yeah.
With
One
those tests, we will
possibility.
take and do the manual and everything else. Sorry to interrupt you. Can go.
No, okay. Yeah, no, I was gonna say if time is an issue, like you have to wait 10 or 15 minutes, you can always change the lamp for a higher power one, same size, and then I don't know if the ballast need to be changed, but I think if you go from 30 watts to maybe 45 watts, you can use the same. But this is something you can check later. That's very easy to do. Okay, excellent. So yeah, I'm very happy. We saw the processing and how it's going. So Tom, so this is recorded. I ask you to send me after record. You send me the link for it's download. So I send to Terence and Chad and somebody else that's everybody that's in the group, so they can follow these, and if there is any help they can do, we can write. That's very nice. Yeah.
Anderson, I just wanted to see if I could indicate how simple the biological tests are.
Okay,
very
please. Yeah.
This is
an
example of the biological spore strip. It's in a sterile package, so I'm not going to open it, but it's the small white strip, which I hope you can see there inside. You simply open that up, and then what I did was I carefully punctured a small hole in it so that I could hang it on a paper clip, essentially, inside the chamber. Now, you have to be very careful to use sterile components. And one of the mistakes that I made was I thought alcohol would sterilize the equipment. It turns out that these bacterial spore strips, or the spores, are insensitive to alcohol. So they actually store these strips in 40% ethanol solution. So alcohol does not work to sterilize, but UVC does work. So at Mass General Hospital, Harvard Medical School, they actually take the forceps or tweezers that they use to handle these, and they put them in the chamber along with the spore strips. And they decontaminate the instruments that touch these strips while they are decontaminating or testing the decontamination through the spore strips. Then this is the vial of media, and you basically just take the small strip, and what I did was just put a scissors above it and just clip the strip off right below the paper clip, and it just fell right in the media. When I used the alcohol sterilization procedure and brought the strips back to my office, the experiment didn't work. Even one single bacteria, the doubling time is about 2 hours for these bacteria. And so if you wait 48 hours, that's 2 to the 24th power. So that one bacteria grows to about 10 to the 8th bacteria, and that's enough to change the color of the media from this color to clear. And so you can't have any bacteria at all. Anything that's on your forceps or tweezers is enough to contaminate the experiment. You need to be very careful about the sterilization, but the actual process of doing the testing is extremely simple. And then you just basically, the media can either be held at room temperature or it can be incubated at about 37 degrees centigrade. I have a small heating block on a hot plate, which keeps it at that temperature. And then if you wait 2 or 3 days, there'll either be a color change in the media or not. and it's a digital test. Either you've completely sterilized and killed all the bacteria, or you have not. It does not give you any indication in between that. So it's a digital test, but it's very simple to do. So and I know Anderson did it not with the spore strips. He did it with using a known amount of bacteria in a petri dish. That's actually almost a better way to do it because there it is actually quantitative. You can count the number of bacteria that survive. And so even if you don't do complete sterilization, if you get a suppression of 10 to the minus 3 to 10 to the minus 4, that level is called decontamination. So a 3 log reduction is decontamination, 6 log reduction is sterilization. And decontamination is considered to be sufficient to reuse N95 masks. And what Anderson did allows you to determine whether it was full sterilization. It's an analog measurement, it's not digital. So you can tell whether it is sterilization or decontamination. So Anderson, I just wanted to explain how simple these tests are. It was the first time I've ever done it. And when I did it the first time, where I was very careful with how I handled the strips, everything worked fine. But then I found out when I got a little bit careless and also made a mistake that I thought alcohol would do it, it didn't work. But that's because I'm not a biologist. I'm like you, a physicist. And so I don't, I'm not as familiar with these things. My daughter, who is a biologist, was very quick to tell me how I had done it incorrectly. And so I think you should be, if you need to do these tests, you can do those in a physics laboratory. It does not need to be, these bacteria are not pathogenic. So they won't hurt you. In fact, the Cumulus bacteria is found in soil. That's where it comes from. So it's all around us. It is very UV resistant. So it has about the same cross section, or requires the same joules per square centimeter as the virus. So it's a very good surrogate for the virus. And I would hope your hospitals would allow that to be a local test, that once Anderson does the virus testing, that all you do is need to just to use these strips as a surrogate, and that would be enough for them to be comfortable that it's working. So I just wanted to go through that, Anderson, just to assure
yeah, that's very good. Yeah. In fact, I found an equivalent here, but I did not buy because I had the lady making this for me. But what I'll do for the student, I'll send to you, but I'm going to buy those here. I don't know how long they'll take to come. I'll buy a bunch and then I can send to everybody. So I'll deal with that and let you know. If it's going to take a long time, maybe Tom, you can send some to us. It should be able to come through UPS, come to my home, and then I'll let you know by Monday.
Yes. I have 500 of these vials sitting in my office here. So I have plenty to ship to you if you need them.
Okay.
Yes, so,
I'll let you know. Okay.
Very good.
Okay.
Excellent presentation and really great progress. Just want to emphasize that as you guys make progress and make these measurements, we will be sharing these with the rest of the world, with people in Africa and India and Mexico who are also eager to build these devices. And I think if we can information and get the validation done and a testing protocol that these can follow, this will help everybody in the world. And so it is great that you guys are making such good progress. And please, let's have regular meetings so we can keep up to date. This was an excellent meeting, so thank you all.
Okay, very good. Thanks everybody. And then we'll be talking, and then when we have some more progress, maybe in 2 weeks' time, we should have another meeting.
Yes.
Okay?
Very good.
Okay. Thank you.
Okay.
Bye-bye. Have a nice Thanks, Tom. I think now you're gonna have breakfast. Early there.
Thank you, everyone.
Ok. Bye-bye.
Okay. Bye-bye. Thank you.
Falo com vocês aí depois, então. Tá? Deixa eu ir atrás das coisas aí, a gente fala. Tchau, Luiz.
Tchau.
Tchau. Obrigada.
Tchau.
Tchau.